What if the reason we can't find the definitive theory of everything isn't because the math is too hard, but because the universe itself is suffering from a form of cosmic amnesia? Here's the compelling scientific curiosity. When we look at the laws of physics, they appear flawless and symmetric at a fundamental level. Yet our observable universe is made almost entirely of matter, with antimatter having all but vanished after the Big Bang. This isn't just a minor imbalance, it's one of the greatest unsolved problems in physics. To explain it, we must invoke unknown mechanisms that violated a fundamental symmetry of nature. Now consider this. Theoretical work on black holes, particularly the work of physicists like Stephen Hawking and Leonard Susskind, points to the black hole information paradox. This paradox suggests that information about what falls into a black hole seems to be fundamentally lost when the black hole evaporates, which violates a core tenet of quantum mechanics, that information must be preserved. The initial loss of antimatter and the potential loss of information in black holes might be different manifestations of the same underlying flaw in reality. Perhaps the pristine, symmetric laws of physics we seek to discover are the original, healthy state of a system. Our asymmetric, matter-dominated universe, with its apparent tolerance for information loss, could be the corrupted or decayed version. Are we not studying the fundamental laws of the universe, but rather the symptoms of its decay? Our entire cosmic history, from the first second after the Big Bang to the eventual evaporation of the last black hole, might not be the story of perfect physics unfolding, but the story of a universe slowly forgetting its own initial conditions. And we are the temporary, conscious patterns that have emerged within its fading memory. This frame is deeply engaging because it reframes the entire scientific pursuit. It suggests that the cracks we find in our models aren't just puzzles to be solved, but are potential archaeological evidence of a deeper, more perfect reality that has been lost, making us cosmic detectives trying to reconstruct a forgotten past. Forget for a moment the terrifying textbook image of a black hole, a monstrous singularity, shrouded by an event horizon, a cosmic predator from which nothing, not even light, can escape. I want you to replace that with a different image, one of a cosmic egg, a perfect, self-contained, and impossibly dense seed of all potentiality. Now consider this. What if the Big Bang was not a singular, spontaneous eruption of space-time from a metaphysical nothingness, but was in fact the violent, transformative process of our universe being born inside such an egg? The hook, the tantalizing clue that drags this idea from the realm of pure science fiction into the arena of legitimate, if fringe, theoretical physics, lies in the oldest light we can see, the cosmic microwave background. This fossilized radiation, the cooled remnant of the universe's fiery infancy, should be, according to standard cosmological models, almost perfectly smooth, a uniform tapestry of minute temperature variations. But it isn't. It's flawed. It possesses strange, large-scale anisotropies, cold spots, and alignments often referred to as the axis of evil by frustrated cosmologists that stubbornly refuse to fit the neat narrative of an isotropic, homogeneous explosion from a point. What if these aren't mere statistical flukes or instrumental errors? What if they are cosmic birthmarks, the indelible imprint of a prior reality, a parent cosmos, etched onto the very fabric of our newborn universe? Imagine the moment of our creation, a colossal star in a meta-universe, a universe of a higher dimensional order than our own, collapses. Its core, compressed beyond any conceivable density, forms a black hole. But in this metacosmos, the laws of physics might be subtly different. The formation of the event horizon, the point of no return, might not be a one-way street into infinite density, but a phase transition of staggering proportions, a bounce, where the inward-rushing material of the parent star and its surrounding space-time is reborn inflated, and transformed into a new, expanding reality, our universe. The CMB anomalies, then, could be the quantum gravitational echoes of the structure of that parent star, the turbulent shock waves of its collapse, frozen into the first light of our cosmos. A message in a bottle from a world we can never otherwise see, telling us that our entire history is the interior story of a celestial object, viewed with horror from the outside. This idea reframes the Big Bang's initial conditions, the precise fine-tuning of its expansion rate, its initial low entropy state, not as arbitrary starting points, but as natural consequences of the black hole formation process in a higher dimensional bulk space, a process that naturally gives birth to an expanding, cooling, and structured universe within. We are taught that our universe is expanding, and not just expanding, but accelerating, driven by a mysterious force we call dark energy. But what if this expansion is an illusion, a misinterpretation of a deeper, more profound truth? From our perspective inside the cosmic egg, we see galaxies flying away from us, their light stretched into the red, and we extrapolate backwards to a singularity. But consider the view from outside our universe, from the metacosmos. An observer there would see a black hole. And what is the defining feature of a black hole from the outside? Its event horizon. Now here is the mind-shattering pivot. What we perceive as the future and the ongoing expansion of our universe might actually be the process of us and all space within our cosmos approaching our own event horizon from the inside. The edge of our observable universe, some 46 billion light-years away, isn't a spatial boundary we could ever reach. It's a temporal one. It is our local manifestation of the black hole's event horizon. The redshift of distant galaxies isn't just a Doppler effect from them moving through space. It is a gravitational redshift of epic scale, the light struggling against the immense, all-pervading gravitational field of the black hole we reside in, stretching and losing energy as it climbs upward toward us, from regions closer to the central potential. And dark energy, that mysterious force accelerating the expansion, it could be the tidal force of our cosmos's central singularity. Not a point in our past, but a location in our future. We are not flying away from a center, we are being radially stretched towards a final state. This is where the holographic principle crashes into our narrative with the force of a revelation. This principle, derived from black hole thermodynamics, suggests that all the information describing a volume of space can be encoded on its boundary surface. If our universe is a black hole, then the three-dimensional reality we experience, every star, every planet, every thought in your head, is a holographic projection from the information stored in 2 dimensions on the event horizon that encloses us. The finite information density of that horizon translates directly into the finite number of quantum states in our universe, explaining why vacuum energy isn't infinitely large. Our perceived expansion and acceleration is the continuous unfolding of this cosmic hologram, the rendering of reality from the event horizon's data shell inward. We aren't in a black hole, we are a projection of a black hole's surface. If our universe is a black hole, then the laws of physics are not fundamental abstract mathematical truths, they are the emergent properties, the local bylaws of this specific cosmic structure. They are the unique climate inside this particular egg. The speed of light, c, the gravitational constant, g, Planck's constant, h. These are not arbitrary numbers, but fixed parameters determined by the mass, spin, and charge of our parent black hole. They are the DNA of our reality. The reason we find 4 fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, is that these are the necessary, stable interactions that can arise and persist within the complex, high-energy environment of a black hole interior, undergoing inflationary expansion.
This perspective offers a stunningly elegant solution to the unreasonable effectiveness of mathematics, a puzzle that plagued 20th century physicists. Mathematics is effective at describing the physical world not because the universe is made of math, but because both the universe and our mathematical intuition are products of the same structural logic, the logic of a black hole's information processing architecture. Our brains, themselves complex structures evolved within this cosmos, are wired to perceive the patterns inherent in the system they are a part of. Now, let us venture to the most speculative, the most profound implication, the nature of the central singularity. In standard black hole physics, the singularity is a point of infinite density where the laws of physics break down. But in our universe
contains an estimated 2 trillion galaxies. Within those galaxies, stars live and die, and in their death throes, the most massive ones collapse into black holes. We have observed them, studied them, and feared them. But if our macro-universe is itself a black hole, then every stellar mass black hole within it is not a mere curiosity. It is a child universe, a budding cosmic egg within the larger egg. Our cosmos is not a solitary entity. It is a fecund reproductive system, a fractal matryoshka doll of realities nested within realities. When a star collapses in our universe and forms a black hole, the extreme conditions at its core, the phase transition of the event horizon, trigger a new internal Big Bang, giving birth to a baby universe with its own potentially different physical laws. These laws would be variations on a theme, mutations in the cosmic DNA, determined by the specific mass, spin, and charge of the parent star. Some of these baby universes would be stillborn, collapsing instantly or expanding into barren, particle-less voids. Others might flourish, giving rise to their own complex structures, galaxies, stars, planets, and perhaps even life and consciousness. This is the true cosmology of a multiverse, not an abstract landscape of disconnected bubbles, but a literal, physical genealogy of realities. Our universe was born this way, from a star in a meta-universe, and it gives birth to new universes in turn. This creates a stunning ecological model for existence. The food for this cosmic ecosystem is matter and energy. A star in our universe gathers hydrogen, forged in the Big Bang and previous stellar generations. It fuses it into heavier elements. When it collapses into a black hole, it isn't creating a true singularity of infinite density from our internal perspective. It is packaging that processed matter and energy, that information, and using it to seed a new reality. The Hawking radiation that slowly evaporates black holes from our external view could be the thermodynamic exhaust of this internal universe's processes, a faint signal of life within. In this grand ecology, life is not a random accident. It is a highly advanced, complex state of matter that acts as a catalyst for the processing and organization of information, ultimately making the universe more fertile, more capable of giving birth to robust and complex offspring universes. We and every living thing are part of a cosmic reproductive cycle of unimaginable scale and beauty. A scientific idea, no matter how beautiful or philosophically satisfying, is worthless if it cannot be tested. So how do we falsify or verify the extraordinary proposition that we live inside a black hole? The answer lies in pushing our observational and experimental technologies to their absolute limits, seeking the subtle fingerprints of our cosmic parentage. The first and most crucial test is in the detailed statistical map of the cosmic microwave background. The next generation of space-based observatories must look for specific, non-Gaussian patterns, specific types of twists, correlations, and vortices that are predicted by models of a black hole bounce, but are absent in standard inflationary cosmology. They would be the quantum gravitational scars of the formation event. Secondly, we must delve into the realm of gravitational wave astronomy. The merger of two black holes in our universe creates a specific chirp signature. If our universe has a non-trivial, large-scale spatial curvature imposed by its nature as the interior of a larger black hole, it could leave a subtle imprint on the propagation of these gravitational waves across billions of light years, a kind of cosmic acoustics revealing the shape of our chamber. Third, and most speculatively, if the event horizon of our universe is a holographic screen encoding our reality, then there is a fundamental graininess to space-time at the tiniest possible scale, the Planck length. Certain experiments in quantum gravity, perhaps involving ultra-precise measurements of the flight times from distant gamma-ray bursts, might one day detect this pixelation of reality, the direct signature of our holographic nature. But the final test is not just observational, it is existential. It requires a redefinition of what existence means. If this model is true, then the search for a theory of everything is not the search for a set of equations that govern our universe from the outside, like a machine's blueprint. It is the search for the meta-laws that govern the process of cosmic reproduction itself, the laws that determine how the physical constants of a child universe are inherited from its parent universe. We are not separate observers looking at a universe. We are patterns within the universe looking at itself. To know the universe is, in a very literal sense, for the universe to know itself. The final experiment is the continued, conscious, and courageous act of inquiry itself. By asking the question, what if we live in a black hole? We are not just doing science. We are the cosmos performing its own ultimate introspection, peering into its own deepest nature, and, in doing so, perhaps taking one step closer to understanding the magnificent, terrifying, and glorious truth of what it is.